Have you ever joined a Kaggle Titanic competition and tried to push your rank as high as possible? If you're into data science, you've likely faced this challenge. The goal is to predict passenger survival with high accuracy using machine learning. But here's the catch. Many data scientists overlook interpreting these models, which can threaten your job in the age of AI automation. Winning a Kaggle competition doesn't make you a top data scientist. It's the ability to explain and apply insights that sets you apart. Despite the rise of generative AI, humans still outperform machines in certain areas. AI processes large data sets well, but humans bring experience, intuition, and common sense, turning data into meaningful stories that drive action. One powerful way to interpret machine learning models is through the 5 WHYS analysis, a root cause framework for solving business problems. In this video, I'll show you how to apply the 5 WHYS analysis to the IBM HR Analytics Dataset from Kaggle to uncover key issues and present them in a way that drives business impact. Let me first quickly explain why the 5 WHYS analysis is a game changer for understanding business problems. If you stick until the end of this video, I will give you bonus point on how feature importance in machine learning can be used to identify and select important variables for improved decisions. Okay, let's get started. What is 5 WHYS analysis? As a data scientist, building accurate machine learning models with tools like XGBoost or Random Forest is definitely rewarding, but the truth is, nobody really cares. If you can't explain your model, data science's job impact will be severely limited. Business leaders and product teams need to understand why the model makes certain predictions, or they may view it as a black box, unreliable and risky to deploy. To gain trust and ensure adoption, model explainability is a must. One effective approach is the 5 WHYS analysis, a simple method developed by Taiichi Ono, part of Toyota Production System, for investigating the root cause of an issue by asking why, typically 5 times, until the systemic issue is identified. It is often used in lean manufacturing and continuous improvement, or Kaizen initiatives, to ensure for more effective and long-term solutions and prevents the recurrence. Let's look at how Toyota used the 5 WHYS framework to improve manufacturing productivity. On the assembly line, the production of engines was halted because one of the machines stopped working. By applying the 5 WHYS. First, why did the engine assembly line stop? It is because the machine that was supposed to install a specific engine part stopped working. Second, why did the machine stop working? It is because the motor that powered the machine overheated. Third, why did the motor overheat? It is because the cooling system for the motor failed. Fourth, why did the cooling system fail? It is because the coolant level was too low. Finally, why was the coolant level too low? It is because the coolant pipe had a small leak that was slowly losing coolant. From this example, the stoppage resulted from a small leak in the coolant pipe, causing coolant loss, motor overheating, and machine failure. Toyota responded by replacing the pipe, improving maintenance checks, and contemplating a coolant system redesigned to prevent future issues. This example highlights how the 5 WHYS helped Toyota identify the root problem, ensuring a long-term solution rather than just fixing the machine shutdown. Over time, the technique has been adopted in industries beyond automotive manufacturing, including healthcare, IT, finance, and even HR in an organization. Let's apply 5 WHYS analysis on IBM HR Dataset from Kaggle.com. Let's clarify the context of this dataset, which contains IBM employee performance records linked to attrition. It includes multiple variables such as age, monthly income, department, distance from home, education level, environment satisfaction, job satisfaction, and years with the current manager. Key factors like education, environment satisfaction, job satisfaction, performance rating, and relationship satisfaction are scored numerically, with lower numbers indicating poorer outcomes. The analysis objective is to identify employment records at IBM contributing to attrition, which stands at 16% as benchmark among 1,470 employees. A classification machine learning model will predict potential attrition or resignations, and consequently, feature importance analysis from model reveals 6 key variables impacting attrition: job satisfaction level, job role, overtime, salary, education level, and job level. We will apply the 5 WHYS analysis framework to interpret the models. First why question would be, why do employees have high attrition chance? To answer the first why, we can formulate a hypothesis or educated guess that could be answered by examining the job satisfaction levels with corresponding number of employee and the associated attrition percentage. The data shows that lower job satisfaction correlates with a higher attrition rate of 23%, compared to the standard benchmark of 16%. The second why would be, why are employees dissatisfied with their job? We can further investigate by analyzing different job roles and overtime status using a 2x2 table analysis. The first two columns show a total of 1,470 employees, while the next two columns represent 289 employees with the lowest job satisfaction, rated 1. The final columns display the likelihood of low job satisfaction for each job role and overtime status. Notably, the highest percentage, 29% of low job satisfaction, comes from 62 lab technicians working overtime. The third why question is, why are there so many lab technicians dissatisfied with their role? To answer this, let's consider common sense and salary factor. The dataset shows that lab technicians earn an average of $3,000, which is about 50% of the average salary for other roles like manufacturing directors, research scientists, and sales executives. This significant pay gap may contribute to dissatisfaction, but we believe that the issue may not be purely financial. The fourth why question: why are lab technicians, despite earning less, dissatisfied with their role? The key factor here should be affected by education level. A bar plot comparing job roles and education levels shows that lab technicians, like other roles, are dominated by bachelor's degree holders. In fact, many lab technicians are overqualified for their role, as their job typically requires only a 2-year diploma or associate degree. So, the final question becomes, why are bachelor's degree holders dissatisfied with their role? The answer lies in the correlation between job level and education. A 2x2 table analysis reveals that many employees with a bachelor's degree are assigned to job level 1, which is the lowest level, comparable to employees with only a high school diploma. In contrast, employees with diplomas or advanced degrees, for example, master's or PhD, tend to be assigned higher job levels, level 2 and above. This mismatch between education level and job level may explain why many bachelor's degree holders, especially lab technicians, feel dissatisfied with their roles. So this is how I perform data analysis by asking 5 times. In fact, it's important to recognize that you don't always need to ask 5 whys to uncover the core issues in the real job data analysis. Sometimes, just 3 good questions can reveal deep insights, especially when the answers are sufficiently detailed. Now that we've identified the root causes of employee attrition, especially among lab technicians, it's time now to translate these insights into actionable recommendations for senior management. First, reevaluate job roles. Align job descriptions with actual qualifications to address underutilization, especially for overqualified lab technicians. Second, improve career progression. Create clearer pathways for advancement, offering higher job levels to employees with qualifications that match their skills and goals. Third, adjust salaries. Address salary disparities, particularly for lab technicians, to ensure fair compensation aligning with qualifications and responsibilities. Fourth, manage overtime. Reduce overtime or provide additional compensation to improve work-life balance, especially for roles with high overtime demands. Finally, offer training and development. Provide upskilling programs to help lab technicians and other employees advance in their careers, boosting both job satisfaction and retention. By creating a clear storyline for your analysis and recommendations, you can link root causes to actionable solutions, making them more persuasive for senior management. Data analysis is an evolving art that requires ongoing improvement and, consequently, adjusting analysis as needed is necessary to ensure logical and coherent narrative stories. I encourage you to download the IBM HR Dataset from Kaggle.com and practice applying the 5 WHYS method by yourself. The dataset contains additional variables, like total working years experience, standard hours, job involvement, and others, that could also contribute to employee attrition. Remember, the key is asking the right questions and digging deep enough to uncover the true root causes in a coherent manner. Let me clarify what feature importance really means, as I mentioned earlier in part 2 of this video. Feature importance determines the contribution of each feature to predictions in a machine learning model, such as decision trees or random forest. Therefore, understanding feature importance fosters trust between data scientists and business users as it allows you to explain and justify the model's decision-making. After splitting the dataset into training and testing sets during model development, a random forest, or XGBoost model, is trained on the training dataset. The feature importance is then extracted using built-in functions, which generate importance scores for each variable used in the model. These scores reflect the relative contribution of each feature to the model's predictions. Usually, top 5 variables are enough to explain model interpretability. Before selecting variables for a model, there are a few important points to keep in mind. First, feature importance scores. Sum to 1 or 100%. This means that if a variable, say X, has an importance score of 25%, it contributes 25% to the model's overall prediction. Second, all variables must be in numerical form before applying feature importance functions. Third, for categorical variables, but they have natural order such as education level in bachelor's, master's, and PhD, you can convert them into numerical values by assigning integers based on their rank. Fourth, for categorical variables without natural order such as colors in red, blue, and green, you can use techniques like one-hot encoding to convert them into unique individual variables. Now, if you're eager to dive deeper into data storytelling and learn how to communicate business insights in a coherent way, check out these 2 videos. I'll cover tips on framing data in context, crafting a chronological storyline, applying the 3-act Hollywood structure, and humanizing data. If you found this video valuable, hit the subscribe button so you can continue receiving tips and insights that will take your data science career to the next level. And don't forget to leave a comment. I'd love to hear how you're planning to apply these tips. Thanks for watching.